Welcome back everyone. Here I will show you the functionality of the cursor. Go click on the cursor from this block, measuring block, the menu block. Right now cursor is off, so I can click on the soft menu, soft key. I will do cursor manually and select the horizontal cursor for now. The cursor A and cursor B, it says cursor A is at 5.2 volts, cursor B is at minus 8.480 volts. And let's go back to channel 1. The probe is at 2x. Let's change it to probe to 1x because it was showing me twice the value. Let's back with the soft key, pressing it again and again until I go back to channel 1. Let's go back to cursor now. Now cursor shows that cursor A is at 2.64 volts. Maybe it's a little high, so this button I can move the cursor low or high and move it at the top. Horizontal cursor. Close to 2.6 volts. Cursor B. Now the bottom one will be moving. Cursor B is set to the bottom. It says minus 2.64 volts. So from here, this is another way to measure the peak-to-peak voltage. It shows a 5.2 volts. Now I want to measure the time between two peaks of the signal. So that is one period. I want to measure the period. I select the cursor again. This button again. Now this button will move the cursor left and right. Right now cursor A is going to move. Cursor B is moving. Sorry, I was on cursor B before. Let's move to the peak of one of the wave. So this is one of the wave. So this is 2.18 milliseconds. Cursor B, X value 2.180 milliseconds on the screen. And let's go to cursor A, the soft key. Now I can move the solid line. I want to measure the period. AX, the cursor X is at 1.160. So 2.180 minus 1.160, it's nearly a millisecond, which says that yes, the frequency is almost a kilohertz from these measurements. Let me get the cursor turned this off. This is one way to measure the time and voltage. Let's put another set of connectors, one to the scope, that goes the scope probe on channel 2 for example, and I put another one on channel 2 of the function generator. I don't see anything here on the screen because channel 2 output is activated, but channel 2 here is not activated. Let me activate that one. Now you see that I see two signals. Since they are almost identical, very difficult to see. Both channel 1 and channel 2 are 2 volts per division. Both are sinusoidal both have 1 kilohertz, both has 5 volts peak to peak. Let's change channel 2 output here to a little bit different. Let's make it let's make the frequency, change the frequency to 2 kilohertz. So I can see that the blue line on the function generator has more oscillations, twice as many. Let's change the time base. So you can see that when the yellow one, the output of 1, makes 1 oscillation, the blue one makes 2 oscillations. And let's align the phase, which we cannot because there are 2 different phases. Let's change the starting phase. Let's make it a different value, so you can see that we can there is a phase difference of 45 degrees between these two at the starting phase. But remember that there are 2 different frequencies, so this phase difference meaning is not very meaningful. If I go back to channel 2 on the frequency and change it back to same frequency, 1 kilohertz, now the phase difference does have some meaning. We can say that align the phases, go to channel 1, now channel 1 has 5 volts peak to peak. Go to amplitude, change it a little bit different value. So channel 1 has different signal. Let's make channel 1 as a square wave. So we can see that channel 1 is square wave, channel 2 is sinusoidal. I can say that channel 1 is ramp, and channel 2 is a sinusoidal. I can make channel 2 change. Let's go to output 2 by the middle one, shifting. Now let's make it a square wave. Now channel 2 is a square wave and channel 1 is a triangular wave. Let's go back to the sinusoidal wave. Channel 1, let's make it sinusoidal again, and let's make the amplitude of channel 1 back to 5 volts. And let's set the phase so that we can shift one wave onto the other one. Let's go back, change it to whatever value I want. Now I have to measure the phase difference of these 2 waves. I will go to the cursor, turn it on, and since I now want the time delay, so I will turn on the vertical one. So cursor A, I will move the cursor A, then move the cursor B, And from the values from the left, I can calculate the delta t, the time difference between these two waves, and from there I can multiply it by 2 pi to get the phase difference in radians, or can multiply it 360f, 2 pi f, or 360f. The frequency is already known to be 1 kilohertz. 360f times delta t will give the phase difference between these two waves, or 2 pi f delta t will give the phase difference, but this phase difference will be in radians. Let's go back to menu one more time. It says source is channel 1, slope upslope trigger. Let's take out channel 2 from here. So there is no signal going into channel 2. And I'm saying the source is channel 2. And you can see that the signal is jumping because it is now triggering by channel 2. Whatever the noise signal is coming by channel 2, that is triggering. So we should change it back to channel 1. Alright, that's all for today. Now make different wave functions, waveforms, different frequency and different phase and amplitude, measure different values and get used to with both the function generator and the oscilloscope. Thank you all.